Welcome. These notes cover a simple reusable software component, Class Die. When we want to play dice games, we will take advantage of having this pre-built software component that represents one singular die. Here is the description of our class. A die is a single six-sided cube that can abstractly be represented by an integer face. The face holds the value of 1 through 6 based on the face-up representation of the die. A die has a roll method that randomly changes the face showing on the die. The toString method returns a string that graphically shows the face of the die. There is a setFace and getFace methods for the face that are provided. A die face can only be set to 1, 2, 3, 4, 5, or 6. Here are the die class members. We have a private integer named face. This will represent the face side up of the die. We'll have public method roll, which will simulate rolling the die. This will be a void method. We'll have a public setFace that accepts one integer input to change the face of the die, and a public int getFace method that will return a copy of the face value of the die. Now when we code the set and get methods, we are thinking about them from outside the class looking in. So setFace is designed to change the value of the face, and getFace is designed to retrieve a copy of the face of the die. Public toString method will provide a string representation of our die. Here are some important object-oriented programming techniques that you will see in this code. The first is the encapsulation of the die in terms of its properties, the face on the die, and its actions, the rolling of the die. These are built together inside class die. The second important object-oriented programming technique we are using is to provide secure coding by keeping all the variable members of the class private. So you'll notice that the face of the die is kept private, which means we can only access that from within the class. We will provide appropriate set and get methods for member face, and that allows the other parts of the program that need to use the face of the die to access it, but only through the methods we provide. The toString method, which will provide a string representation of the face of the die for easy output to the screen. Here is our sample code. First we'll take a look at class die, and then we'll take a look at the driver file, Play with Dice, that instantiates two die objects. Here's class die. We see that it consists of one variable member named face that represents the face up of the die. It's kept private. The constructor of the die sets the face value to 1 initially. Now this is an important consideration because recall that if we did not set the face of the die, it would have an initial value of 0, which makes no sense for a die. The roll method uses the random number generator by calling the nextInt method with a value of 6. NextInt with an input of 6 will return either 0, 1, 2, 3, 4, or 5. Now we need 1, 2, 3, 4, 5, or 6, so we add 1 to the result we get. That will give us 1, 2, 3, 4, 5, or 6. Here is the setFace method. It has a precondition listed here that the input value must be in the range of 1 through 6. If it's not in the range of 1 through 6, we will not change the face of the die. This explains a little bit about why we keep the face private. The only way to change the value of face is through this method, and it allows us, the programmer of the class die, to filter out any invalid input that somebody might either maliciously or mistakenly provide for the face of the die. We certainly don't want it set to -7 or 8, those values don't make any sense. The get method returns a copy of face's value to the caller. Again, because we keep face private, we provide this interface method for another part of the program that's using the die to be able to get the value. We will see this used in our driver file, Play with Dice. And our last method is the toString method. The toString method is designed to provide a string representation of our die. We're going to show it face up. Here we see the use of what's called a switch statement. Alternatively, we could use an if-else-if nested structure. If the die face value is 1, we want to show it with just 1 pip inside the square. If face has a value of 2, we show it with the 2 pips, 3, the 3 pips, 4 has 4 pips, 5 with 5, and there is 6. So face up is a string that's being built to hold the pictorial representation of the face of the die. Then we return the face up as a string value. Let's take a look at how this gets used in the Play with Dice file. Play with Dice class has the main. Inside main, we create 2 new die objects named Dice1 and Dice2. Notice the call to the constructor. We invoke the constructor by using the new keyword and then the name of the constructor, which always has the exact same name as the class. So our die class has a die constructor that's going to set the face to value 1. Then we print out Dice1 and Dice2 as a string using the toString method. Next, we will roll the dice. After rolling the dice, we will show them again face up and total their 2 face values and print that out. Okay, let's run the program. So initially, we see that the 2 dice, after rolling the dice, dice number 1 now has face of 4 and dice number 2 has a face value of 2, and our program reports that you rolled a 6. Here is the code where we set the total equal to dice1.getFace, which has a value of 4, plus dice2.getFace, which has the value of 2, which totals 6, and then the system out print line stating you rolled 6. And I wanted to look at the constructor one more time. The important features here that we keep variable member face private and we provide a constructor. Notice the constructor has the exact same name as the class. It should always be made public so that we can instantiate objects using it, and it does not have any return type. Its purpose is to create objects, and our die objects will always start out with a face value of 1. Happy coding!